In the late summer of 1971, final preparations were being made on Amchitka Island in the remote Aleutian Island chain of Alaska for Project Cannikin. Cannikin was a United States Atomic Energy Commission underground nuclear detonation to proof test a warhead for the Spartan missile of the Safeguard Ballistic Missile Defense Program. The nuclear device and instrumentation canisters were lowered in a hole lined with 54-inch diameter steel casing into a mined cavity 5,875 feet beneath the surface of the island. The hole then was completely stemmed or backfilled with material designed to assure that the radioactivity produced by the detonation would be completely contained underground. The Cannikin device was predicted to have a yield of less than 5 megatons. Prior to the test, everyone left the island except for 242 persons who were at the control point at the northwest tip of Amchitka, about 23 miles from ground zero. The closest places where people live are military bases at Adak and Shimya, about 200 miles away. Following the day of a violent storm with winds exceeding 100 miles an hour, the Cannikin experiment was conducted on Saturday, November 6, 1971, at 11 a.m. Bering Standard Time. While water turbulence was created in the immediate vicinity of Amchitka, no tsunami or large ocean wave was observed or recorded. Ground shock resulting directly from the detonation was felt as a rocking motion at the control point 23 miles away and was faintly perceptible at military bases on Adak and Shimya. There is no record of ground motion being felt at more distant locations. Seismic recordings of the test showed a body wave magnitude of 6.8 and a surface wave magnitude of 5.7 as a direct result of the detonation. A high-speed camera was aimed at the cableway extending between Ground Zero and the recording trailer park. The energy produced by the detonation caused the surface of the island directly above the device to be raised momentarily approximately 25 feet. The dark material seen rising from the ground was loose dirt from roads and construction areas. The lighter material was water from some of the many small lakes on the island and surface water from rain. As was predicted, all of the radioactive material from the test was contained underground. No radioactivity resulting from the test has been detected or is expected at the surface or in the sea. Surveillance will continue for a number of years. Specially designed shock mitigation mounts were installed on trailers containing data recording instruments. The slow-motion camera at the recording trailer park recorded the reaction of the instrument trailers to the 2 pulses of ground acceleration caused by the detonation. Some rocks and sea stacks along the coast were damaged by ground motion. Preliminary indications were that the beach and ocean floor in the near vicinity of the Cannikin site were raised 4 to 6 feet permanently. As predicted, some bioenvironmental effects of Cannikin were noticeable, but no permanent harm to Amchitka's wildlife populations or plant life is expected. As ground motion from the explosion moved through water in lakes near the test point, it created a momentary sharp rise in pressure, and water was thrown into the air. This photo sequence was cut short because of the effect of strong ground motion on the photo station. This view after Cannikin shows that the tundra surface in the ground zero area was considerably cracked and otherwise disturbed, as had been expected. Temporary buildings in this area were badly damaged, but the metal building containing instrumentation cable reels had only minor damage, even though it was located within 250 feet of ground zero. The shock mitigation system in the recording trailer park was satisfactory. All classified experiments designed to measure the device performance recorded data, and preliminary examination indicated that the desired information was obtained. Along the Bering Sea coastline, cliff and turf falls were greater than had been predicted for a 2-mile stretch near Ground Zero. Approximately 38 hours after the test, a subsidence in the Ground Zero area was formed when rock above the cavity created by the detonation collapsed all the way to the surface. When the final collapse occurred, seismic instruments indicated the resulting earth disturbance had a body wave magnitude of 4.9. A survey indicated an irregular surface subsidence about 1.5 miles across, with a maximum depth of about 55 feet.